You push on box G that is next to box H, causing both boxes to slide along the floor. As shown in the figure, the reaction force to your push is...
Yes. The reaction force to your push is what?
A.
The push of G on H, this is the reaction force?
No. The... one minute, mister. It's B, right?
The push of H on the G, H on G, that's it. Again, the push, this is the force. When you want to find the action reaction force, Muhammad, you have to look at what acting on what.
Okay.
So if you push on G, this is force, reaction will be G on you. You reverse it.
Oh, yes.
Okay, so the answer is what?
So it's C, right?
Yes, it's a C.
Okay.
The G against you. The action force, U on G, the reaction G on you. You just reverse the two objects. You have to do this in the actual reaction force. Let me go down, go down, go down. Let's take this example. Someone read it. And let's go for it. And Muhannad.
Yes.
Read question 20, Muhannad.
A truck is using a hook to tow a car whose mass is 1/4 that of the truck. If the force exerted by the truck on the car is 6,000 Newton, then the force exerted by the car on the truck is C, 6,000 Newton.
A truck is using a hook to tow a car whose mass is 1/4 of the truck. If the force exerted by the truck is 6,000, then the force. So what was your answer?
C, 6,000 Newton.
Yes, the same one, 6,000 Newton.
Wait, hold on. How did he do it?
It is the same, Karim. Action reaction. It doesn't. He's telling you the mass just to manipulate you. Okay. So don't get confused by telling you the mass is quarter or half the mass. There's nothing related to the mass. It's only about the force, action, and action force. So let's go for question 22. Omar, yes, 22. Go ahead, Omar, 22.
Okay. The figure shows two boxes with M1 greater than M2 that are on a level frictionless surface. We can apply a horizontal force F either toward the right on M1 or toward the left on M2. The magnitude of the force that the box exerts on each other is. Can I see the choices, mister?
Yes, see the choices. That's the choices.
Okay, so it's asking for the forces that the boxes exert on each other. The same in either case.
Okay, how did you find it? Or just by luck?
What do you mean? How did I find it?
So, how can you explain why did you choose this choice? Is this a choice? Explain to us why did you choose that?
Because, for example, when you touch something, like when you put your hand on the desk, it exerts the same force as you pushing on the desks.
Okay.
It's a universal law, so that's how I know the answer.
This is not the right answer.
Okay, so what's the right answer, Mr.?
So the figure shows that two boxes with M1 and M2 that are on the level frictionless surface. There is no friction here. We can apply horizontal force either toward right on M1 or toward left on M2. I can push from here or I can push from here, from right or from left. The magnitude of the force that the boxes exert on each other. If I push from the right, there will be force from M1 on M2. If I push from the left, there will be force from M2 on M1. Are they the same or different? Or there is one greater than the other one? This is the question. To to answer this question, you have to know that when you exert force here, these forces will be distributed on the two masses according to the mass. The higher one will take more mass. The higher mass will take more force. For example, if I exert 100 Newton to the right from here. So this 100 Newton will be distributed over the two masses here. M1 will take, for example, 70 Newton, and M2 will take 30 Newton from the 100 Newton that exerted on the right. معايا عمر عشان كده هتجاوب برضه مش انا اللي هجاوب.
Yes,
طيب.
I'm with you, Mister.
Okay, bear with me. If I exert it to the left, 100 Newton, only small portion will be exerted on M2, and the rest of the force will be exerted on M1. So what I want to say is that the force is distributed depending on the masses. If you have more than one mass, you are exerting force on them. So if I exert from the right, you will have a force M1 on M2. It will be different if you exert from the left. M2 and M1 will be different. Which one is greater? M1 and M2 or M2 M1? Omar.
M1 obviously is greater.
No, Omar. M2 is greater because 70% of the force is used in moving M1. Only left is 30 Newton that will exert on M2 by M1. So only 30 Newton will be exerted here. Let me take it. Let me take it for you.
Mister, I'm confused.
I will take it. Yes, a minute. Okay, that's it. بص يا سيدي. I exert a force here by 100 Newton. Okay, Omar. Okay, the force that I'm exerting here is 100 Newton. خلاص. This 100 Newton will be distributed, there is no friction here, will be distributed over the two masses here. The higher mass will take more of the force. Okay, I will assume that this will take 70 Newton. What is left, Omar? What is left?
30 newtons.
30 Newton. 30 Newton, this is the force left. M1 will act on M2 by 30 Newton. Okay.
Okay.
This is case 1. In case 2, I'll make it in blue. I will exert 100 Newton from the other side here. 100 Newton. Okay. This 100 Newton will be distributed over the two masses. This will take 30. ها صح كده؟ What is left? 70 Newton
70.
will be, yes, 70 Newton. They are not the same. The greater mass will act with lower force, and the lower mass will act with greater force. Okay, Omar?
Yes, okay, I understand.
Let's go back to the question and find the answer. Oh, that's not recorded anything. So what's the answer here? You just mention it. The answer is A, B, C, D. What's the answer?
It's either B or C.
Yes.
It's wait يا مستر.
ارجع لك تاني ورا؟
لا بس I think it's B يا مستر.
Larger force applied toward right. Larger force toward right. Let me see. Larger force toward right. Toward right, not larger force. It's a 30. In this example.
It doesn't. We need to know the direction of the force. صح?
Yes, I tell you the direction. I tell you, you exert force either to the right or to the left. Which one will cause greater force between the two boxes? If you exert to the right or exert to the left, the greater force will be to the what?
Okay, so the greater
to the left, because you consume only. Yes. The greater two box will appear only if you exert the force from the left, because 70 Newton will be left, or you consume a small portion of the force on the small mass, and the left is the large portion of the force. So if you exert the force from the left, you will have more force left to act between the two boxes. So the answer is C. Larger force is applied toward left. Toward left. Thank you, Omar. Let me go back down. Yes, I want someone to answer this question. And it will be Yahya. Yahya.
Yes.
Read this
Okay.
question.
An object on weight W is in free fall, close to a surface of the Earth. The magnitude of the force that the object exerts on Earth is during free fall equal to W.
An object of weight W is in free fall close to the surface of Earth. The magnitude of force that the object exerts on Earth is, yes, what's your answer?
C.
C, yes, equal to the weight because
Yeah.
it's action reaction force. Action reaction force. Thank you, Yahya. Let's take a problem here. Abdullah Al-Milham, you have to participate with us. Abdullah. يا عبد الله. طبعا عبد الله بيشغل البتاع وبيمشي. ده اللي انا افهمه يعني. ان هو مش معانا اصلا. عبد الله. Okay, Abdullah. How can you answer? Can you write the answer for this question? I will read it and you will answer it, Abdullah. Okay, I will read for you. A person is using a rope to lower a 5 Newton bucket into a well with a constant speed of 2 meters per second. What is the magnitude of the force exerted by the rope on the bucket? What is the magnitude of the force exerted by the rope on the bucket? So, Abdullah, can you answer this question? Let me see your answer. Okay, read it again here as you wish and find the answer. What's your answer, Abdullah? The answer is C. Okay, let me see if the C. 5 Newton. Yes, that's true. Bravo, Abdullah. صح. Okay, and that's because it's action reaction force, guys. The weight is downward, and the weight is downward, or the bucket on the rope will act on the bucket by the same force, which is 5 Newton upward. Okay. And yes, this is in the elevator problem. Ahmad Anwar. Ahmad,
Okay. A person who normally weighs 700 newtons is riding in a rather swift elevator that is moving at a constant speed of 9.8 meters per second. If this person is standing on a bathroom scale inside the elevator, what would the scale read? More than newtons, less than 700 newtons, 700 newtons? It could be more or less than some. Okay. It says here, if the person is standing on a bathroom scale inside the elevator. Understood. Okay.
Constant speed. This is the clue. Constant
So
speed is moving with constant speed.
So is he going down or up? ما يفرق يعني.
Is moving at constant speed of this. It's constant speed down or up doesn't make a difference if it's constant speed. But if it was acceleration, there is a difference. But speed, constant speed doesn't make any difference. Yes.
So it's C? C?
So yes, the C. Because this constant speed, this means that yes, the weight will not change. If you have acceleration upward, it will be more than 700. If it's downward, it will be less than the acceleration downward. It will be less than 700. And we have the same question here. Someone will answer it. Thank you, Ahmed. Let's pick the next one. And Abdullah جاوب. Ahmed Tawfiq al-Mish'al. Answer this question, Ahmed.
Yes, Mr.
30, question 30, answer it. Last question.
A person who normally weighs 700 Newton is riding on an elevator that is moving upward, but slowing down at a steady rate. If this person is standing on a bathroom scale inside the elevator, what would be the scale read?
So, he's
700
moving-
newtons.
Listen first. He's moving, position weight 700 Newton, riding an elevator that is moving upward. So the direction of movement upward, not the direction of acceleration, but slowing down. So if it's slowing down and moving upward, what is the direction of acceleration?
The direction of what?
Acceleration.
Down.
Yes, acceleration is down. So if the acceleration is down, if this person is standing in the bathroom scale, what would happen to the weight? Will be more than or less than or equal to 700? It depends on the direction of acceleration. Acceleration here is downward.
It will be more than 700.
More than 700, are you sure?
Because the acceleration is down, Mr.
Yes, when the acceleration is down, we increase the weight or decrease the weight.
It's supposed to increase the weight.
When the acceleration is down, it decreases the weight.
Okay.
So the answer will be less than 700. It decreases the weight. Thank you guys for listening, and see you tomorrow in the next chapter, inshallah. We'll start new chapter tomorrow, inshallah. Thank you. Have a nice day.